Let's consider what are what calls. So basically, when we are talking about calls, then our interest should be what the tendency of a vector to circulate around a given point. Are we together? Now, how do you now represent your calls, or what is your calls denoted to be? Now, let's say we are given an electric field. We are given an electric field, whether that field is a scalar or a vector. We are just given an electric field, which is what F, and they said your electric field is what Fxi plus what Fyj of what Fzk. Now, if you are now asked to represent your call, how do you represent it? We basically represent our call in this form. So you have gradient times what the field given to you. So this is how we represent what calls of a particular what vector given to you. Are we together? Now, in solving calls, there are two approaches in solving calls. The first approach is what we call the multiplication by expansion. Multiplication by expansion, and that's what we've been doing since we started this course. You can go through our episodes. So the first approach is what we call the multiplication by expansion, while the second approach is what we call the matrix method, or the matrix what approach. Are we together? So you can use each of these methods in solving what the calls of a particular what field vector given to you. Now let's use the matrix approach because that's the easiest approach in solving calls of particular vector. Now, if you want to apply the matrix method in solving this electric field vector that was given to us to be what f of xi, fyj, and what fzk. The first thing you always do is to check the electric field given to you, if it is a scalar or a vector. What we have here is a vector. Reason being that we have what direction and what magnitude. Are we together? Now, if you want to apply this in our matrix method, the first thing is to pick out your component and represent your components to be in column, such that you simply have this to be I, J, and what K. Now the next thing is to assign your what your symbol. Assigning your symbol, this will simply give you what this is plus, minus, and plus. That's what you do. Now, what's the next thing? The concept behind calls is we're differentiating for your I component, we are differentiating in respect to X. For your Z component, J component, we are differentiating in respect to Y. And for your K component, we are differentiating in respect to what? Z. So what we have here will simply be what? Partial of partial X, partial of what? Partial Y, and partial of what? Partial Z. Now, on the I column, remember what are we having here? We're having what? Fxi. So on this column here, which is your I column, you simply have here to be what? Fx. Here will be what? Fy, which is what we have here. And on this column, we have what? F what? Z. Are we together? Now, with further ado, what is now the concept of matrices? When we want to solve matrices, remember we are given three components. So we basically have what? Three component spaces. What do I mean? Here, you will simply have for your I component. And when you want to get your I component, what we do is the concept is we are covering this, assuming you are not seeing your I component. What will you be seeing? You'll be seeing your J component and your K component. What are now the parameters on these two components? We are basically having partial of partial y, and we have f of y, and we have here to be partial of what? Partial z, and here we have what? F of z. This is now your I component. Now the next thing is you have your minus here, so here will be what? Minus j into your j component. Assuming you are not seeing your j component, what will you be seeing? You'll be seeing I component and K component, right? Now, what are the parameters in both components? So we basically have for your I components, we are seeing partial of partial x, and we are seeing f of x here. Here we are seeing what? Partial of what? Partial z, and we are seeing what? F of what? Z here. That is the concept. Now, what's the next thing we have to do? The next thing is to apply the next component, which is plus k. So you have your plus k here to be what? Remember, we are not seeing your k component. What's the concept? We are seeing I and j. And looking at I and j, we have partial of partial x, and here we have f of x. On this part, we have partial of what? Partial y. Then we have f of y here. Now, what's the concept behind your matrix method? The concept is when you want to multiply, you are multiplying this, then you are subtracting with what? The multiplication of this. I don't know if you understand. I have to change my pen. Now changing my pen, let's say we have our black pen. Let's go to a new page. Now I said if you want to multiply your matrix method, what you do is you multiply with what we have here and you subtract with what you have here. The same thing applicable here. We multiply with what we have here, then we subtract with what you have here. Are we together? Apply the same concept here. You multiply with what you have here and you subtract with what you have here. Now let's take some examples for more clarification. Let's take some examples for more clarification. So if we were given our first example to be, we were asked to find coil what? Coil A. And what's your A? Your A is simply what? 4x square minus what? 3x square yj. This is what? I component. So you have I here, and you have plus what? 3yz raised to the power of what? 4. This is our key component. Now, what you are seeing is you are given a particular field vector to be what? A to be equal to what? A is equal to what? 4x square I, 3x square yj, and what? 3yz 4k. What you should do is confirm if what you have here is a magnitude, is a vector or a scalar. And we can see what? Magnitude and direction, and that tells us that our electric field vector of A is a what? Is a vector. Are we together? Now, with further ado, let's go over to the approach in solving your electric field vector of the coil A given to us. Now, if we want to solve this, we are going to use the matrix method. Using the matrix method, you first bring out your components, which is what? I, j, and k. Now, bringing out our components, we have I here, we have j, and we also have what? K. What you do is you assign your symbols plus, minus, and what? Plus. Now, what do you do? On this part of your equation, on the I column, you simply have partial of what? Partial x. Here you have partial of partial y, and here you have what? Partial of what? Partial z. On this colon, you have what? 4x square. Here you have what? 3x square, and 3x square y, and here we now have what? 3yz raised to the power of what? 4. Are we together? Now, the next thing you do is you want to simplify using the matrix concept. And what's the matrix concept? The matrix concept simply says we are keeping out each of these components, and we are what? We are deducing what the values will be. That's the concept of matrices. Now, the concept is very simple. Now, we'll simply have for your I component, which is what we are keeping, we're covering your I component. What are now the components? What are now the parameters we are now seeing for your j and k component? That's the meaning. So here we'll simply have partial of partial y, 3x square y, and here we have partial of what? Partial z, 3yz raised to the power of what? 4. That's for our first component minus your g. Now remember, your j is having a minus sign here. Now, since your j is having a minus sign, you simply have your j component to be what? Partial x, which is your I component, and 4 what? X square. And on this side, we have partial of partial z of what? 3yz raised to the power of what? 4. What's the next one? Plus what? We now have plus k, which is our key component. So assuming we are not seeing k, what are the parameters we are seeing? We are seeing our I and j, right? Now, if you see I and j, what are now the components? What are now the parameters inside I and j? We'll simply have your k to be partial of what? Partial z, partial of partial x, sorry. Here you have what? 4x square. On this side, you remember we are on k component, so we are not seeing k, assuming we are not seeing k. So we are seeing just I and j. So here you simply have partial of what? Partial y. And here you now have what? 3x square y. Now, after doing this, the next thing is to apply your multiplication concept. Your multiplication concept is simply saying, use this to multiply with what we have here and subtract that with the multiplication of what we have here. That is simply telling you that what we have here, if you want to multiply, you are multiplying this with this. And what you are doing is you are differentiating your parameter here with respect to what? Y. That's the meaning. Remember, if you differentiate 3yz raised to the power of 4 with respect to y, that will give you what? For your I component here, you simply have this to be what? 3z raised to the power of 4 minus. If you differentiate what we have here with respect to z, are we seeing z here? No. So since we are not seeing z here, this will give you what? 0. Let's go over to our j component. We have minus j, and what we are doing is we are multiplying this, we are subtracting with what? The multiplication of this. Now, if you multiply what we have here with 3yz raised to the power of 4, what are you doing? You are simply differentiating what we have here with respect to what? X. Are we seeing x here? No. Since we are not seeing x, this will give you what? 0 minus. Remember, what do we have here? We are seeing what? 4x square. 4x square is telling you that since you have 4x square here, what is now your 4x square? Remember, you are differentiating with respect to what? Z. So since you are differentiating with respect to z, what is now z here? Are we seeing z here? No. This should simply give you what? 0. That's the meaning. Now, what's the next one? We have plus k, right? And on our plus k, we are differentiating what we have here by multiplying with respect to what? X. And that will give you what? If you differentiate this, this will give you 6xy. And on this side, are we seeing y here? So if you multiply and you differentiate, you'll simply have 0, and you have minus what? 0. Now, what are the parameters we are seeing left? The only parameters we are seeing left is what? 3z raised to the power of 4, because if you minus this with 0, you still have the same parameter. So what you do is you take this parameter and you multiply it with the component outside. And for that particular question, we have 3z raised to the power of 4 of your I component minus what you have here will be 0, right? So what we have here will be 0. So you have minus 0, right? Plus your k component. What are you left with for your k component? 6xy. So you have 6xy multiplied by your k, and that will give you what? 6xyk. Now, if you want to simplify this further, this will simply give you the coil of our field vector f will simply be equal to what? 3z raised to the power of 4i plus what? 6xyk. So this will be your answer. Now, looking at our answer, what are we seeing? We are seeing that our answer is having what? Magnitude and what? Direction. So is it a vector or a scalar? What we simply have here is a what? A vector. Thank you.